Have you ever thought about a floating volcano? Because that's pretty much what we're looking at today, the LNG bunker barge. We're going to go inside this incredible and frankly incredibly dangerous machine to see the engineering that allows massive ships to get refueled right at sea with one of the most volatile substances on the planet. I mean, really, how do you even begin to handle something like that? It's a constant, high-stakes battle against physics. You're basically trying to control a substance that wants to do two things at once: flash freeze everything it touches and, explode. And that right there is the dual threat that makes LNG so unbelievably difficult to manage. At minus 165 degrees Celsius, it is cold enough to make normal steel shatter like glass. But if it leaks and hits the air, it instantly creates this highly flammable cloud of gas. So it's not one problem, it's two crazy extremes happening at the exact same time. So how on earth do you contain a cryogenic beast like this? Well, the first solution is an absolute masterpiece of specialized engineering, all designed to keep that LNG exactly where it's supposed to be. The best way to think about the barge isn't as just a giant fuel tank, but more like a complex, self-contained circulatory system. Every single part of it, every pipe, every valve, every pump, is purpose-built to survive and work in that mind-numbing cold. And this whole system, it has its own language. Operators have to navigate this maze of pipes using a super strict color code, and every color has a critical meaning. You see cyan? That means pure liquid LNG is flowing through. Orange is for LNG vapor. And if you see a flash of red, that means the firefighting water system is primed and ready to go. And honestly, every single piece of this hardware is a marvel. You've got these specialized pumps that can handle that crazy minus 165-degree cold. But the most crucial part might just be the connections, the emergency release couplings. Think about it. What happens if the two ships drift too far apart? These things are designed to automatically snap the connection and instantly seal both ends, preventing what would be a catastrophic spill. It's just brilliant. This number really shows you the incredible precision we're talking about. To get these massive tanks ready for a new load of LNG, they have to be cooled down incredibly slowly, at a maximum rate of 10 Kelvin, or 10 degrees Celsius, per hour. If you go any faster, the thermal shock could literally shatter the tank's structure.
Okay, so containment is one thing, but what about the invisible threat? A gas leak. How do you possibly detect a danger that you can't see or smell?
Well, to solve for that, the barge is equipped with what's basically a sophisticated nervous system. It's this whole web of gas detectors all over the vessel, and they are constantly sampling the air, able to pick up on even the smallest, most localized leak of natural gas.
And the system is smart. It doesn't just scream danger at you, it communicates with nuance. A level 1 alarm is like an early warning. Hey, heads up, something's not quite right. But a level 2 alarm? That means a much higher, more dangerous concentration has been found. That is a critical alert, and it demands an immediate, decisive response. And this shows you that deliberate escalating response. It's like a story in 4 acts. First, you get a warning. Then the crew investigates. If things get worse, a full alarm goes off. And that's when the automated systems kick in and take immediate, decisive action. Ultimately, these sensors aren't just looking for any gas. Their real job, the crucial job, is to make sure the air on that barge never, ever hits that perfect, dangerous mix required for ignition, what's known as the flammability zone. But what happens in the absolute worst-case scenario? What if a fire does break out, despite all the precautions? That is when the barge executes its emergency playbook, which is a series of powerful automated countermeasures. The very first play is the emergency shutdown, or ESD. It is one single decisive action. Someone presses one button and fail-safe valves slam shut across the entire system, instantly isolating the LNG and stopping all transfer operations cold. But what if a fire is about to happen? The barge uses this remarkable chemical agent called Novec 1230. Now, this isn't like water or foam. It works by absorbing heat so incredibly fast that, just like the manual says, it can essentially extinguish a fire before it even truly gets started. It just snuffs out the chemical reaction of combustion itself. And we're not just talking about one fire extinguisher here. This is a total flood system that protects the barge's most critical and vulnerable spaces. The generator room, the cargo switchboard, the pump rooms. Basically, the mechanical and electrical hearts of the entire operation are all shielded by this system. And for any threats coming from the outside, there's the water curtain.
When it's activated in an emergency, it creates this massive shield of seawater that just cascades down the hull, protecting the barge's own structure from either the intense heat of a fire or the intense cold of a spill. But all of this incredible technology, the sensors, the shutdown systems, the chemical suppressants, it's only half the solution. The final, and I think the most important problem to solve is human fallibility. The operations manual makes this perfectly clear. The ultimate responsibility doesn't rest with a computer or some automated system. It rests with the highly trained human operators on board, who are legally responsible for the safety of everyone and everything around them. Because let's face it, any system can fail. Any sensor can be wrong. So at the end of the day, safety really comes down to the crew's expertise, their rigorous and mandatory training, and their constant, unwavering vigilance during every single moment of the operation. This right here is a perfect example of their preparedness. These aren't just some vague guidelines. They are the precise, drilled-in steps for putting on a self-contained breathing apparatus. Every single step, from adjusting the straps to that sharp inhale that starts the airflow, it makes the abstract idea of safety incredibly real and tangible. So in the end, this floating volcano isn't just a story about managing a dangerous fuel. It's a powerful lesson in the intricate partnership between human expertise and sophisticated technology. It's a partnership of trust, and it's happening quietly out on our oceans every single day just to keep our world moving.